In this video, we will see about regenerative braking and how it works. Regenerative braking is an energy recovery mechanism that slows down a moving vehicle or object by converting its kinetic energy or potential energy into a form that can be either used immediately or stored until needed. Typically, regenerative brakes work by driving an electric motor in reverse to recapture energy that would otherwise be lost as heat during braking, effectively turning the traction motor into a generator. Feeding power backwards through the system like this allows the energy harvested from deceleration to resupply an energy storage solution such as a battery's capacitors. Once stored, this power can then be later used to aid forward propulsion. Because of the electrified vehicle architecture required for such a braking system, automotive regenerative brakes are most commonly found on hybrid and electric vehicles. This method contrasts with conventional braking systems, where excess kinetic energy is converted to unwanted and wasted heat due to friction in the brakes. Similarly, with rheostatic brakes, energy is recovered by using electric motors as generators, but is immediately dissipated as heat in resistors. In addition to improving the overall efficiency of the vehicle, regeneration can significantly extend the life of the braking system. This is because the traditional mechanical parts like discs, calipers, and pads, included for when regenerative braking alone is not sufficient enough to safely stop the vehicle, will not wear out as quickly as they would in a vehicle relying solely on traditional brakes. The most common form of regenerative brake involves an electric motor functioning as an electric generator. In electric railways, the electricity generated is fed back into the traction power supply. In battery electric and hybrid electric vehicles, the energy is stored chemically in a battery, electrically in a bank of capacitors, or mechanically in a rotating flywheel. Hydraulic hybrid vehicles use hydraulic motors to store energy in the form of compressed air. In a hydrogen fuel cell-powered vehicle, the electrical energy generated by the motor is stored chemically in a battery, similar to battery and hybrid electric vehicles. Practical regenerative braking. Regenerative braking is not by itself sufficient as the sole means of safely bringing a vehicle to a standstill or slowing it as required, so it must be used in conjunction with another braking system such as friction-based braking. However, some cars like the Chevrolet Bolt can bring the vehicle to a complete stop on even surfaces when the driver knows the vehicle's regenerative braking distance. Current regenerative brakes do not immobilize a stationary vehicle. Physical locking is required, for example, to prevent vehicles from rolling down hills. Many road vehicles with regenerative braking do not have drive motors on all wheels, like in a two-wheel drive car. Regenerative braking is normally only applicable to wheels with motors. The regenerative braking effect available is limited, and mechanical braking is still necessary for substantial speed reductions to bring a vehicle to a stop or to hold a vehicle at a standstill. On real hills with real traffic speeds, the magnitude of potential energy recoverable during the descent of a vehicle at a slower speed than its terminal speed is substantially greater than that recoverable by bringing the vehicle from even the terminal speed to a complete stop. Regenerative and friction braking must both be used, creating the need to control them to produce the required total braking. The GM EV1 was the first commercial car to do this. I hope you enjoyed this video. For more interesting videos, please subscribe to our channel.